Apollo 11 landed on the moon 53 years ago. Now, NASA wants to return to the lunar surface with the Artemis program, the beginning of human colonization involving the moon. One of the main challenges that scientists are encountering is the ability to send their instrumentations on different vehicles that are capable of providing a sustainable way to do science. The Rolling Miners' bio-inspired robots, the Fengari-bots, will collect necessary information for the lunar surface for diverse projects. By being able to carry scientific instrumentation for research, or even be adapted for other purposes, like architectural sites to be built in the coming years. The south pole of the moon is critical for colonial lunar research because it contains ice and valuable resources needed for sustainable living on the moon. Inspired by pill bugs and their ability to roll and traverse different terrains, the Fengari bots will be able to collect vital information on caves, craters, and lava tubes by utilizing different sensors like LiDAR to sense their surroundings, legs to perform uphill and slower locomotion, and the innovative idea to curl up and roll downhill for faster transportation. The Fengari bots will have the ability to act as a swarm by integrating machine learning to their bots. This allows them to communicate among each other, collect information, and create maps to better understand the moon's geography. The Rolling Miners is a team formed by 10 students from New Mexico Institute of Mining and Technology, with a diverse background like business, computer science, astrophysics, mechanical engineering, biomedical engineering, and physics. The members of the Rolling Miners are Sarah Lantot, James Montoya, Chase Dunaway, Celeste Isolde, Florist, Juliana Barstow, Suzanne Eisenberg, Forrest Good, Natasha Shaw Davis, Shengyu Zhang, and William Janney. And our advisor is Dr. Masasta Hassanalian.
Mechanically, the Fengari bot takes inspiration from several of the pillbug's biological features. Centered around maximizing volume for its components during conglobation, the Fengari bot has 6 orange slice-shaped shell segments. Each shell segment differs slightly depending on the mechanisms and electronics housed within and which are necessary for the functional purposes of the robot. In order to roll up, a winch mechanism tightens a set of cables along the bottom edges of the shell and loosens a set of cables along the spine, providing a moment on the hinges between each shell segment. This process is reversed when the Fengari bot straightens out. Extruding from the 6 shell segments, there are 12 independent legs that rotate around the shaft located near the bottom of the shell. This locomotion system ensures that there will always be a stable contact with the ground whilst the Fengari bot is moving. Using finite element analysis, the leg design went through several iterations to find a form that optimizes weight and length while falling well within the factor of safety, so that additional payload can be added to the Fengari bot.
Working on the electrical aspect of the robot, it was essential to provide enough power for all of the subsystems without compromising any of the electrical or mechanical capabilities. The leg operation and winch system use 14 high-torque servos and are controlled via a servo controller. When multiple are in operation, a high current is needed. The onboard computer will use less current to operate, even when connected to the gyroscope and LiDAR sensors. To accommodate for these requirements, 2 LiPo batteries were selected for their high capacitance, where one will power servos and the other will power the rest of the electronics. Adding voltage regulators allowed for the LiPos with higher voltage to be lowered to 5 volts, while also providing a limit on how much current can pass through them. Additionally, the servo wires needed to be extended to reach their designated locations on the robot, and their power cables were combined into one larger gauge wire to power them in a parallel configuration.
Yeah, so I think we're going to just thread through all the way, and then we're going to electrical tape over, and it's all, thank God it's not that shell. Oh, because that shell, this shell's going to be tricky enough. I don't even know if we're going to be able to get those in here. I know, that's going to be a trick. I don't think we are. Which, if not, it's not the end of the world. We already have it on a pulley. don't think it's anymore.
It's from Frios.
The control and navigation of the Fengari bot is governed by a Raspberry Pi microcomputer. The Raspberry Pi connects to a LiDAR, IMU, and servo controller. The LiDAR will allow the Raspberry Pi to detect obstacles. The locations of the obstacles will be fed to a navigation algorithm such as D-Starlight. The machine learning capabilities, such as the navigation algorithm on the Raspberry Pi, will allow the robot to avoid obstacles and pathfind. The navigation algorithm will also be fed the IMU data, so that it is able to determine when it is appropriate for the robot to roll and unroll. To control the robot, the Raspberry Pi will be able to interface with the servo controller to make the robot roll, unroll, and walk. Currently, the prototype also has an Arduino for easy testing of the servo controller, but the final iteration will be controlled solely by the Raspberry Pi. Later iterations will also have an antenna, so that the Raspberry Pis of different robots can communicate with each other. For additional model visualization, the Fengaribot was imported into a virtual reality system. By using the Unity game engine, Blender, and the CAD model, we were able to create the VR system. The Fengaribot's CAD model was imported into Unity along with the custom-built lunar terrain. Unity was then configured to have a space skybox and to allow for virtual reality. The VR system currently allows users to visualize the robot and how it will look on the moon. In the future, we would like to use this VR to manipulate the movement of the robot while it is traversing through different terrain, and hopefully this VR system can be implemented to train astronauts on the moon to operate the robots.